Now you are going to learn about the square number. Square number means it is the number multiple by itself is called a square number. Now in exercise 1.4, the third problem, find the square of the following numbers, that is 17, 203, 1098. We want to find square of the 17, square of 203, square of 1098. The first problem, square of 17. Square of 17 means what I said, the square number, the number multiple by itself. The square of 17 is written as 17 square. So that is equal to 17 into 17. That is a square number 289. Otherwise you not know about the square number like a formula, you have to make a normal multiplication. The second problem, square of 203. So that is 203 square. So that is 203 into 203. So 203 and 203, the normal multiplication you have to make. You get the value 41,209. Now fourth question, examine if each of the following is a perfect square. The first problem 725, second problem 190, third problem 841, fourth problem 1089. For this one we have to check it is a perfect square. You have to use the prime factorization method. For the prime factorization method already you are learned in the previous classes. That is, for a 725, you have to use only prime numbers. First it is end with 5. You select the table 5. 1 5 is 5. Balance 2. 4 5s are 20. Then balance 2. 5 5s are 25. Then again 5. That is 2 5s are 10. Then again 4 is a balance. So the next number is 45. 9 5s are 45. 29 is a prime number. Prime number divided by itself. So 29 one time. So now you have to check. We want to check it is a square number. So how you have to write square number means pair of numbers you have to arrange. For 5, 2 numbers are there. So 29 not our pair. So take and write separately, that is 5 square into 29. For here 5 has a pair, 29 not have a pair. So here 29 does not have a pair. So 725 is not a perfect square. Second and third sum try yourself. Now fourth problem 1089. For it is end with 9. So you have to check 3 table. For 3 3s are 9. Balance 1. So next number is 18. 6 3s are 18. 3 3s are 9. Again 3. 1 3 is 3. 2 3s are 6. 1 3 is 3. 121 is a square number that 11 11s are 121. Then again 11 divided by 11. So now you check the pair of numbers. For 3 have a pair, 11 also have pair. So 1089 is written as 3 square into 11 square. So these two numbers have a pair. So we say it is a perfect square number. Fifth problem, find the square root by prime factorization method. For here given 6 problems, 3 sums I am going to teach to you. The first problem 144. Second problem 256, third one 784, 1156, fifth problem 4761, sixth problem 9025. First problem, square root of 144. So use the prime factorization method. The same way you have to find. For first 2 is possible, it is 72, then again 2 is possible, that is 36, then again 2 is possible, that is 18, then 18 divided by 2 is 9. Then you use the 3 table. 3 3s are 9. Again 3 is divided by 3, 1. So now you have to make a pair of numbers. 2 square, 2 square, 3 square. So 144 is written as 2 square, 2 square, 3 square. Why we are making this as a pair? Because square and square root become cancelled. So you write it as a pair of numbers. So 144 equal to 2 square into 2 square into 3 square. So we want to find the square root value. For this is square root of 144. That is square root. What value we found? 2 square into 2 square into 3 square. Square and square root cancel. Square and square root cancel. Square and square root cancel. So that means 2 into 2 into 3. For inside the root we have a square number. We have a square root. So square and square root become cancelled. So 2 into 2 into 3. So this 2 2s are 4. 4 3s are 12. So therefore square root of 144 is equal to 12. Fourth problem 1156. That is the same way you have to use only prime number. 2 table 5 2s are 10, balance 1 7 2s are 14, balance 1 8 2s are 16. Then again 2 2 2s are 4, balance 1 8 2s are 16, balance 1 18, 9 2s are 18. 289 is a square number of 17 square. So 17 times. Then again 17 is one time. So now for you have to make a pair of numbers 2 square into 17 square. So square root of 1156 is equal to square root of 2 square into 17 square. Square and square root cancel, square and square root cancel. So 2 into 17, that is equal to 34. So therefore square root of 1156 is equal to 34. For a sixth problem, 9025. It is end with 5, so you have to check with the 5 table. 1 5 is 5, balance 4, that is a 40, 8 5 are 40, then 2 is not divisible by 5, so write 0, then you take these two digits together. Once again listen, 1 5 is 5, balance 4, 40, 8 5 are 40, then again 2 divided by 5 is not possible, so you have to write 0, then you have to take these two digits together, that is 5 5s are 25. Then again 5 table, 3 5s are 15, balance 3, 6 5s are 30, 1 5 is 5. 361 is a square number for 19, so that is 19. Then again it is 91. So you make a pair of numbers 5 square, 19 square. So it is 9025 is written as 5 square into 19 square. Square root of 9025 is equal to square root of 5 square into 19 square. Square and square root cancel, square and square root cancel. So that is equal to 5 into 19. That is equal to 95. So therefore square root of 9025 is equal to 95. Sixth problem, find the square root by long division method. Previous problem is a prime factorization method, that is a long division method. Here also given 5 problems. First problem 1764, 6889, third problem 11025, fourth problem 17956, fifth problem 4,18,609. For a long division method, we have to follow some of the rules. First, we have to write the given number in the square root symbol. Then you make the numbers from the start from the right hand side. For like this, you have to arrange a pair of numbers. For pair of numbers means two numbers make a pair. Suppose any number not have a pair, you leave that number as a single digit. So that is for here 1764 is there. That is 1 2. 2 pairs are there. Then you have to follow the second rule is you have to use only the square number, that is 1 into 1, 2 into 2, 3 into 3, 4 into 4, like this you have to follow. Now for the first pair 17. For 17 you have to use which square number is suitable. For that is 4 square is suitable. 4 into 4. 4 4s are 16. Suppose you are selecting 5. 5 5s are 25. Not more than this number you have to find. That is 4 times possible. 4 4s are 16. The rules are same. The normal division, that is 17 minus 16 equal to 1. Then bring down the next pair. Next pair is a 64. Now we have the number 164. Next, what value you find in the quotient that you multiple by 2? That is 8. 4 2s are, that is for this value multiple by 2. That is 4 2s are 8. Now you have to find 8 multiple with which number you get 164. You have to satisfy this number 164. So that is you have to substitute the values. For we have to use a square number, so it is end with 4. So you have to apply some of the rules, that is end with 4 means 2 2s are, 8 8s are, like this number you have to check. First 2 table we have to check, that is normal multiplication. 2 2s are 4, 8 2s are 16. Now you check it is satisfied. So it is 2 times for right here 2 and right in the quotient also, that is 164. Then you have to subtract 0. Therefore square root of 1764 equal to 42. Third problem 11,025, square root of 11,025. For 11,025, first you have to arrange the pairs, that is 1 2 for a 25. here 0 1, this one not our pair, so we keep the last digit as same. That is, now you got to find the values for 1. First you find this is 1. For which square number is possible? 1 into 1, so 1 into 1, so that is 1. Subtract this to 0. Bring down the next pair. 0, it has no value, so you no need to write 0. Bring down the next digit is 10. For now, for 10, here you have a 2. For 1 into 2, what quotient you have, that you multiple by 2, that is a 2. 1 into 2 is 2. Now 10, for you have a 2, for any number you write, any digit you write here 1, 2, 3, that is more than this 10. So it is not possible. So bring down the next digit. Before bring down the next digit, you write 0 in the quotient and in the divisor side. So here 1 0, here 1 0. Now you have to check this 20 along with this some digit, you have to get 1025. So end with 5 means you know which square number is possible, that is 5. Now we have to check 5. 5 5s are 25. Balance 2, 0 into 5, 0, 0 plus 2, 2 5s are 10, 1025. Now you have to subtract these two, it is 0. So square root of 11,025 equal to 105. Fifth problem, 4,18,609. Then you make a pair, for that is 9 0. From the right to left you have to arrange the pairs. Then for the first pair you have 41. For this 41, which square number is possible? So that is 6 is possible. 6 6 are 36. You have to subtract these two, you get 5. Bring down the next pair, that is 86. So now you have the new dividend 586. Here the next procedure is, for what quotient you get, that you multiple by 2, that is 12. Then now we want to find 12 along with this 500, which number you have to write, you get 586. For it is end with 6, so 4 we have to check. 4 4s are 16, balance 1, 2 4s are 8, 8 plus 1 9, 1 4 is 4. Then suppose it is not equal to this, so you have to check one more time, you have to check, that is 5 5. Here what value write, the same value you have to write here, same number have to write here, that is 5 5s are 25, balance 2 10, 12, balance 1 6, that is 625. So more than this number, so 4 is possible. So you have to subtract these two, you get 6 minus 6 0, 18 minus 9 is 9. Then bring down the next pair, that is 9 0 9 0 9. Now the second step, first step complete after that quotient multiple by 2, that is 12. Then you have to write, for now the next number is, for this fully you have to multiple by 2. 64 is multiple by 2, that is 4 2s are 8, 6 2s are 12, 128. That is, that 128 multiple with which number, you get 9009. For end with 9, the square number we have 3 and 7. So 7 is possible. So 7 is possible, you have to check. 7 7s are 49, balance 4, 8 7s are 56, 56 plus 4 60, balance 6, 2 7s are 14, 14 plus 6 20, balance 2, 1 7 is 7, 9. So 9009. So you have to subtract these to 0. So what number you are write here, the same have to write in the quotient. So therefore square root of 4,18,609 equal to 647.